Now let's talk about standalone self-verifiable tokens. So our tokens are basically JSON objects, or they could be represented in some other format, doesn't matter, but the idea is you get basically an object that you can fully verify by yourself independently on anyone else. So you don't basically need to trust any third party or something. You can fully see that this object is correct. So this is our token. It has Genesis record. It have all necessary proofs of its creation, like for instance Coinbase transaction. So let's say we got 10 new alpha coins or Bitcoin or whatever. Then we have a sequence of transactions here, 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 like showing how the ownership is changing. What is different from Bitcoin here? In Bitcoin, when you want to spend specific sum to someone, let's say you want to send 10.5 BTC, you have to collect unspent transaction outputs here, here, here. Let's going to cover up this sum. Let's say 1 here, 3 here, and let's say 6 here, okay? So 1 plus 3 plus 6 makes 10. That's more than 7.5, so it's good enough to cover it. Then you have a transaction itself with two outputs. One is 7.5 BTC and another is 2.5. Well, roughly speaking, I'm not talking about tip collection and stuff like this. So you consume these three things and you produce those two. So now the next recipient of this transaction output, in order to verify its authenticity and correctness, he has to go and verify these and these outputs that have been obtained and they are turned also by some multiple inputs and so on. What we are seeing here? We are seeing here that in order to verify just this output, we basically have to load almost the whole ledger, most of it, major of it, and verify all of it in order to make sure that this thing is correct. Clearly, if you have millions of transactions and assets like that, you still have to download basically the whole state, almost whole state, proving that our token is correct. This is clearly not scalable, right? You can't scale this. You still have to download the whole thing. You still have to download the whole chain in old sense of Bitcoin structure. So that's what I was missing initially, and that's where professors Octobuldes and Mart Serpere came in and suggested locally verifiable model where each coin, each asset is independent. It doesn't depend on anything. So if we minted 10 alphas here, they all stay here. We never join them with something else. I get 5 other alphas from somewhere, so and so on. So if I want to pay someone 7.5 alphas, let's say, I need to collect enough number of tokens on my own custody that are going to cover this sum. Of course, I cannot make exactly 7.5. It could be something else. It could be 10, like in our case. It could be 1 alpha, 3 alpha here, 6 alpha here. But I transfer them all in parallel to the recipient, and also, if necessary, I can split some of these coins here, like this one, for instance. So I can split it in 3.5 and 2.5. So in fact, I'm going to have 2 new coins here. But still, each of these coins have linear history, so it could be fully verified independently from others. So that's what was also, this ingredient was also extremely important to make practically fully self-verifiable system. In this manner, your Unicity wallet system just stores collection of these coins with their linear histories that you can fully verify by yourself. And the common thing, what everyone has to verify, is proof of work blockchain. That's it. So each of these tokens or coins, in order to verify it, you need a blockchain for everyone, and then a hash pass for each of the transactions it had in its history. That's it. So with this kind of approach, you can basically reach the practically scalable, horizontally scalable system where every participant can verify fully their tokens. So even the goal is basically like even smart electric bulb in your toilet should be able to verify that payments to it have been done correctly without calling any external parties and trust them. Okay?